opportunity to be in the presence of really some exceptional greatness in terms of scientists in our lifetime. So whilst we're having a conversation, I do want you to use this opportunity to think of some questions. I've already said this to you, because I know that Sir Paul has very generously said that he will also welcome questions from the audience. But with no further ado, I'm going to welcome Sir Paul onto the stage. So, I think you will absolutely appreciate the fact that we're exceptionally privileged to have you with us here this evening. And whilst I know that we've asked you to come and speak about policy making in science, and we'll absolutely come to that shortly. But for many of us, I think being in a room with a Nobel Prize winner is rare and possibly unique, if you don't mind saying so. Unlike, I'm sure that's not the case for you, but for the rest of us, that is absolutely the case. But I suspect before you really get into science policy, many of us would be really interested if you would mind in your own words, give us a bit of an overview of your career journey, how you embarked on this journey, and what's it like to have such an exceptional and successful scientific career.
Well, first can I just say it's a pleasure to be here. It's a pleasure to speak at the council, to see the awards, and actually it's such a fantastic location. I didn't come from an academic family, it was a working class family, and I couldn't get into university either. So I worked as a technician in the Guinness Brewery. Those of you old enough to remember the Guinness Brewery on Park Royal was where I was for a year, until eventually I was let into Birmingham University, which is where I did my first degree. Since then, I've worked in a variety of places, universities and research institutes in the UK, continental Europe and the US, and I'm not going to go through all of them. I did my PhD in Norwich, though, in the University of East Anglia, where I happened to be born. My family came, or half my family came from Norfolk. But then spent time in the University of Edinburgh, University of Sussex, short periods in the University of Bern, and also University of Copenhagen, and then went to the Imperial Cancer Research Fund in London before becoming a head of department in the University of Oxford. It looks as if or sounds as if I can't keep a job. Maybe there's some truth in that. I didn't last too long in Oxford, actually, because I have to say it was fantastic students, fantastic colleagues, but an institution that was a bit static, if you know what I mean. And I didn't sort of thrive there. I came back to run the research in the Imperial Cancer Research Fund in Lincoln's Inn Field in London, and then I came in charge of that. And perhaps some of you will remember the shops, the ICRF shops on the High Street, and then came up with the idea of merging it with what was called the Cancer Research Campaign to make Cancer Research UK. So that was my suggestion, and I did play a role, a big role actually, but with others to put that together. So then I spent 7 years in the United States running Rockefeller University, which is a research university, before coming back and founding the Crick and the Royal Society. Why did I get interested in policy? There is a reason for it. The sort of research I do could be classified as reasonably useless, by which I mean I am driven by my own curiosity to study things. However, I felt guilty about it. So, how could I deal with my guilt? And the way I dealt with my guilt was, well, I could spend, say, half my time doing research, following my curiosity, and I could pay back to society the other half of the time of doing things to do with the organisation of science and policy of science, which I found, to my astonishment, I was actually quite good at. So the reason I got into it was almost to deal with my conscience, that I could contribute with that stuff as long as they left me alone to pursue whatever I liked in the lab. And that sort of worked.
Gosh, and even during that conversation, you've articulated some more quite exceptional achievements. What is that? What of your achievements, both professionally and personally, are you most proud of?
It's a couple of experiments in my laboratory, really, which had virtually no reason to work and which did open up understanding of the cell cycle. Can I spend a minute or two on that? We're all made of cells, and cells reproduce themselves going from 1 to 2 through a process called the cell cycle. That process underpins the growth and development in all living things, so it's a really fundamental process. And when I started working on it, which is in the 1970s, there was very little, really very little known, or almost zero known, about how it could be controlled. And I used a genetic approach working with yeast, with a simple yeast, and looked for mutants which were defective in the cell cycle, so they couldn't divide. But I was actually interested in the control of the process. If you have genes which, when you knock them out, stop the process, they don't necessarily control it, they're simply necessary for the process. And then by accident, I stumbled onto a mutant when I was working in Scotland, which will be relevant in about a minute and a half. I stumbled upon a mutant by accident, I wasn't looking for it, under the microscope, which divided at a small size. Now you would think, well, why is that interesting? And then it was interesting because the cells, and it's a cylinder, normally grow to this and then divide, right? But if they can undergo the cell cycle faster than they can grow, they will divide at a smaller size. So what I was seeing under the microscope was a gene that made the cells reproduce themselves quicker. So it was a bit like the accelerator on a car. It was a controlling process rather than a necessary process. I didn't look for it, I never thought of it. Nature gave it to me. The only thing I did was sort of recognize it pretty quickly for what it was. I went running around the lab shouting at everybody, this is the key of life, all that sort of stuff, to which people thought, oh, go away, Paul, the usual thing. So I was always doing stuff like that. And, but it was actually the first entree into what's now called cyclin-dependent kinases, which control the cell cycle. Experiment number 1. I didn't do anything, it just was given to me. Second one, I worked out with my lab the gene network which controls cell division. It was in yeast. Now, honestly, are you interested in yeast? Being honest, bread making, wine, beer. To be fair, most of the world are not interested in yeast. I mean, I understand it, I happen to be obsessed with it, but I realise most people aren't. Okay. So the question was I just studying something that was, for yeast, or did it work elsewhere? I also found myself working in the Cancer Research Institute, and nobody was in the slightest bit interested in anything I did. Okay. So I felt insecure, naturally. Okay. Wouldn't you be insecure? So the question was, do human cells, or for that matter any other cell types, but do human cells control their cell cycle in the same way? So I had a postdoc in a lab called Melanie Lee, and I gave her the project to look for a human gene. This is long before the human genome was sequenced and so on, so this was early stuff. And nothing we did by the regular traditional methods, which I won't bore you with, worked. So then we, in last step desperation, we had a mutant in the gene that was controlling the cell cycle, and therefore the cells couldn't reproduce, right? And I got a gene library, the first gene library made in humans, actually, the very, very first one, a cDNA library for those, and metaphorically sprinkled all the genes over the yeast cells, and arguing that if there was an equivalent gene that did the same job in humans as was defective in yeast, if a yeast cell took it up and it could do the same job, that yeast cell would grow and divide. And therefore I could then isolate, or Melanie and me could isolate that gene back, and we would have the human equivalent. Now that was a crazy experiment, I have to say, and people kept whispering into Moni's ear, Paul's finally gone bonkers, stop taking any notice of him, and she was dogged, did it, and lo and behold, we got something to grow. Lo and behold, we got the gene back. Lo and behold, we sequenced the damn thing, which then took a couple of months. Now it took about 10 milliseconds, but then it took a couple of months. And when it came off the ticker tape, as we had then, it was clearly the same gene. Now, just to put that in context, and I'll shut up, humans and yeast probably shared a common ancestor 1,500 million years ago. We're in the Geological Society here tonight, okay? And I will point out to you that multicellular life was around 650 million years ago, at the pre-Cambrian, Cambrian boundary. Dinosaurs went extinct at 65 million years ago. And that was my homage to geology there. Okay. But this was 1,500 million years ago. So what we were demanding was that the gene would still work, and had been working that way for 1,500 million years. That's why everybody told Marilyn, this is bonkers. And it was bonkers, but it worked. Now the two big advantages. That's the two things I'm most proud of.
Wow, dogged determination by the science of it really paid off in the long run.
Or luck, maybe.
I have to say, I don't think I've ever heard something like that described, and an audience just sits so fixated on every word as well. You certainly knew how to turn that into something which the public could.
Can I comment a bit on that? I told you I came from a working class family. I was speaking to my brothers and sisters, mum and dad and so on, and I was the only one who stayed at school after 15, and I learned to talk to them. It's just part of the family, but in a very straightforward way, and it sort of stuck.
I think it's really, really important, that sort of element of science communication to perhaps a non-scientific audience as well really does help to transfer and translate that information in its widest sense. So you just give me two really fantastic examples of achievements in your professional life. Would you be happy to share some of your sort of more specific achievements in your personal life? I've heard you speak a number of times about your family and your daughters.
Yes, I have two daughters actually, who are now in their 40s. One works for TV. Do we have anybody who watches football on TV here? Hands up. Yeah. Did you watch the Euros final? Yeah. Well, she was running the TV, if you watch it on ITV, running the match, okay? Now, this is not something... We have women in front of the camera, to be blunt with you. There are no women behind the camera in that category. And she's really quite well known. I went to Chelsea to see a match, and I was and went down behind the scene. Everybody knew Sarah Nurse, nobody knew Paul Nurse, for sure. Everybody knew Sarah, so it was quite entertaining. And my other daughter is a particle physicist, okay, who was a full professor at University College London at a younger age than I was made a full professor, as it turns out. And then came to see me a couple of years ago, if this is, I'll say, a couple of years ago, and said, Dad, we've been running the Large Hadron Collider, it's the proton collider, at high energy for now 4 years, and there is no new physics. I said, yeah, that's a bit what I understand. Maybe not good at understanding that, but yeah, that's what I understand too. And I think we need more energy. I think we need a 100-kilometre ring. It says 27-kilometre ring. We need a 100-kilometre ring, and I think I'll be age 70 by the time we have it. So I think this is a must game. So I said, yeah, well, see that, Emily, So what are you going to do about it? She says, I'm going to change fields. I'm going to work on climate change. And I said, that's a very fine idea, Emily, but you actually don't know anything about climate change, which is true. She didn't. She said, no, but I thought I could get maternity cover in one of these think tanks and learn it on the job, a year cover. And I said, Emily, are you intending to give up a tenured, permanent job as a full professor in particle physics where women are gold dust, in UCL, which isn't a bad university, top 15 of the world, and you're going to give it all up for a 1-year maternity cover To which he said, yes, Dad. So what are you meant to say? Do it. So she gets a job as maternity cover. She's there, and she gets it with a climate change committee. Some of you may know what that is. So it's a civil service committee, but it doesn't report to a government department. It reports to Parliament, which means the minister doesn't have control over you. Very important. Minister doesn't have control. We have no ministers. She, after 2 months, her boss comes in and says, you know, we're going to have a team leader position available in a month's time. Would you like to apply for it? She applies for it and gets it. Okay, this is 15 months ago, so she lands on her feet. 6 months ago, she phones me and says, oh, Dad, they're making me deputy director. So it all worked out.
Wow.
I'm pretty proud of both.
Well, absolutely, I can imagine why. I suspect the audience do want me to get back to the reason why we invited you here to talk a little bit more about...
Not about my family, you mean?
Oh, we'll come back to that. Because I think it really is important to see the person behind the scientist as well. I think because, as I think Della said it a moment ago when you were able to join us for the awards.
I was here.
But just how important a role the family and that support network plays in...
And it was the same for me. My family had never, it was my grandfather actually, my genetics were a bit complicated, but you know, he left school at 12, you know, could barely write a sentence. But they were always supportive of me in education completely. You know.
And I mean, it really is incredible as well to have so many family here today, to see our award winners and the fruits of their achievement as well. So it really is, I think it's very important to recognise the fact that it doesn't just happen, it is part of a wider network.
Exactly.
But just bring us back to evidence-based policy. I know we sort of touched on this a little bit at the start, but what really has made you be so involved and so concerned about policy making? I know that's a significant sort of factor for you.
Well, I think science is a great cultural and civilizing activity, you know, knowledge. But it is more than that, because it is with knowledge of the world around us, knowledge of ourselves, knowledge of societies, that we can bring improvements for humankind, fundamentally. So, although I'm what I call a discovery researcher, it's the application of that knowledge which is so important. And you need good policy for science so that you can both generate the highest quality discovery science, but in addition, most effectively, when it's appropriate, translate that knowledge into activities that can improve a lot of humankind. Whether that is improving health, improving agriculture, improving things that make our lives easier, improving transport, all these things are essentially built on science. They are essentially built on science. So our political friends don't always quite get the complexity of that network. They get the bit on the end where we are applying it usually quite well, but then want to control the whole process in that same way, which is sort of top-down decisions about what you have to do. Whereas there is a spectrum in the science activity which is a little more sophisticated, by which I mean at the discovery end, the end where I personally work, it's very anarchic, actually. We rely a lot on individuals and creativity to generate observations, experiments, ideas that lead to understanding of things which are very difficult to predict and very difficult to actually control. And when they're controlled by committees all the time, particularly, you know, people with white hair like me, you just come up with the absolutely bloody obvious all the time. How many times am I going to be told AI is transforming the world as if it's never been said before? You know, it's driving me barking mad. I know very little about AI, but I know enough to know I'm talking to somebody who knows nothing at all. And this is just indicative of the shallowness with which these things are thought about. But the reason I mentioned that that's bottom up, when you come to applications, it's got to be set more top down. You're trying to achieve things like improve the quality of water. We had a quality control somebody earlier. Improving effectiveness in automobile engines, so they use more fuel or alternatives and so on. All of these are more top-down to do with policy. So, in the end, policy is needed to generate the best understanding of things and also to ensure that we do the right things in terms of application. So policy permeates all of science. We have to have the right policy, but it has to be properly thought about. Now, I'm not negative about politicians particularly. I think they work hard and they try hard, but they tend not to get this complexity. So we as scientists, of all different types, have a responsibility to interact with politicians to ensure that they have proper policy. And what they tend to think is good policy is saying we are going to have this objective and this objective, and hopefully it's bright and shiny and everybody will notice it. Okay? And it's more anarchic than they think. The good politicians get that, but it's our responsibility as scientists to actually deliver it. And that's why I think it's so critical. And can I say something else about it? Scientists only tend to talk to politicians when they want more money. Now, what you have to do is make friends with them. Now, if your friend only talks to you when they want to borrow money or get money, they're not your friend. Okay? And it's the same with politicians. You have to work with them when you're not asking for money. You have to work with them to give them advice over things what they have, and not keep banging on saying the world will fall apart unless you increase it to 25%, which is what we tend to do. And then when we think, like we had with the last budget, this sort of panic in the media that science wasn't going to be, is going to be cut, when there was actually almost no evidence that was a risk. Almost no evidence. Which is why I'm always signing letters, but I didn't sign that one because I thought, where is the evidence that this is a problem? Sorry.
And actually really takes us into what I'm sort of really keen to ask you. Your most recent involvement with government policy development was your recent review of the RD&I, it's my mind, it's not the RD&I organisational landscape in the UK.
Yeah.
Where you identified some significant problems, some which were quite long-standing. I think you made 29 recommendations across sort of 5 key themes.
It was a bit of a lot for them to read, actually.
Yeah. So you actually probably have read my mind. I was going to ask you, what do you feel was the most important of those recommendations? And I guess a part B to that question is, what do you think the impact of that review has been or will be going forward?
Well, I did think you might ask me this, and I'm not going to go through 29 of them because I did want to point out, you see, I'm back to the bright shiny things. What they really wanted me probably to say is we need to build something that will make, electric batteries or something, and what I wanted to do was to get at the whole process and shake it up, because I've been at it for many years, and there's just the policy of delivery, which isn't thought about as against the policies of particular objectives. So, having just said to you we shouldn't talk about money, I'm going to start with money, okay, because it is an issue. I tried to find out how much money we actually spent on science, and to my astonishment, the Office of National Statistics hasn't got a Scooby. I'm going to repeat that, it's a disgrace. The ONS have got it wrong for years, and we've been quoting it. And the policy wonks just quoted, that it was 1.5, 1.6%, and it suddenly jumped up to 2.6%. I don't know if you follow it. And we are not actually being able to describe our ecosystem if we just don't know even how much we spend on GDP. I mean, it was shocking, I think. So I had some civil servants supporting me, and we did our best as amateurs to work it out. And what it came out, and I put the figures down here, okay, the amount of money that government spends on science in this country, including all the universities and so on, is 0.46% of GDP, okay? And this puts us 27th in the 36 OECD nations, which have an average of 0.6%. OECD is not G7 or G10. OECD is 36 nations in the world, and we are 27th in it. You know, a superpower science nation, give me a break. It's ridiculous. We are tumbling around at the bottom. US, Korea, Germany spend between 0.7 and 0.9%. We spend 0.46%. And that's just wrong. Now, if we now look at what the government itself spends as against what it gives to others, particularly the university, that drops to 0.12%, which is half the OECD average of 0.26%. What this means is we've stripped our government of scientific advice, which has been eroded over my lifetime. Government's knowledge in departments have been stripped out. Every time they want to save money, they've stripped out scientific research. We no longer have the capability to run our nation for this reason, let alone supporting properly research. So we do have a money problem. It's not that we're fit in the G7 or G10 something, we're right down at the bottom. 2, we haven't thought properly about how to deliver that support. We've focused too much on just direct costs of research, and not what I call the total end-to-end costs of research. Now, in particular, universities have suffered from this. They've actually, it's dramatically increased since Margaret Thatcher, the amount of money that when it was after Margaret Thatcher that money was stripped out of the science, out of government departments and institutes. If you look at end-to-end money, if you support, we have highly trained scientists in research situations who are doing all the typing. No, I mean, typing's important, but I mean, you can pay a typist, and you need support. They have hardly any support. It's absurd. I mean, utterly absurd. Doing good quality science is difficult. It's tough. It's hard. You need time. You need time to think. And they're still spending most of their time writing out bits of papers, not just grants and so on, but everything's got more complicated. We do not provide the support for end-to-end funding. It isn't actually so crazily expensive, and the efficiencies that will be gained from it are dramatic. I run the Francis Crick Institute, and by chance, I just got this great, block of money inherited from the 3 institutes, and they didn't look into what I had to spend it on. So I simply took money out from direct support for labs, but then provided fantastic technical cores and support, and it's enhanced our productivity dramatically. If you just look at it, it's so much more effective. The third point I would emphasise, we do need more diversity of our research performing organisations. 80% of that government spend is in universities. I'm a big fan of universities, but it's not presented in the right way, so they run into trouble there. But the money has all been taken away from government research institutes, the Met Office, which is being shot at because it didn't predict the storms properly today. I mean, you go there, they struggle. It's probably the best meteorological office in the world, as it turns out. I mean, can't bear it when they say this rubbish on the radio about how. Anyway, it's something else. But having research institutes that actually can take specialised, focused attention to problems, and we need a bit more of those. And we also need to build up, as I said, government capability. The public sector research establishments, that's the places that has dropped. I looked at here, it's 1/3 of what it was 30 years ago. 1/3, just to give an indication. Now, maybe it shouldn't go up 3 times, but we need to have a proper discussion about it. 4th thing, reducing bureaucracy, nurturing talent. I'm going to go back to my institute. My institute was reviewed a couple of years ago. It did very well in it. Do you know how many pages I had to produce for that review? Well, I can tell you, 6,000 pages. That's what the Research Council, Medical Research Council in this case, asked. 6,000 pages, which were then sent to reviewers around the world to assess. I want to imagine that you're sitting in Utah or somewhere and get an email with a document that, hey, you can't open because it's so big, and it's 6,000 pages that you're meant to give an assessment on. I mean, what planet are they coming from? It isn't planet Earth. I mean, you know, Venus or somewhere. Anyway, somewhere inhospitable and hot. And as a consequence of that is we are submerged in bureaucracy. Submerged in bureaucracy. And some of it is Treasury implied. They have these rules. They could rip them up. We just invented ARIA. Okay? You know ARIA's. And what did they do? They ripped it all up. But will they rip it up for UKRI and the Research Council? No. What's this? Tell me why. They rip it up for ARIA because they think the bureaucracy is getting in the way. And ARIA is, I don't know, 800 million a year. 8 or 9 billion, they leave them in place. Wow, there's no logic in it. No logic. This doesn't mean we shouldn't review effectively and efficiently. I'm beginning to answer this. This doesn't mean we shouldn't review effectively. We should. But it is not an audit. You know, it's not auditing. It's about quality of work and efficiency and effectiveness, and not rules about whether you should have spent on this or that, and you know, the salaries can't be more than the Prime Minister, and all that sort of stuff. The fact the Prime Minister will retire and then get 5 million a year giving lectures or whatever doesn't come into this nonsense, okay? In addition to getting rid of the bureaucracy, by the way, we need to increase permeability from research institutions between industry and academia, between research institutes and also universities. What else? Well, I might have said something about international relationships. In my review, I said Horizon Europe was very important, the concept. We won that battle. I annoyed Rishi a lot. He sent a civil servant round to tell me off, okay? It's when I had a headline, I think in the Times, and it was on the front page, which said, science, we are fiddling while science is burning, with reference to Nero, when he was just fiddling around, not making any decision about what to do with the Horizon. So we need to have good relations with our close neighbours, good relations across the world. And, you know, this is going to become increasingly important with Trump in place. You know, I mean, his mouth is bigger than his mind, of course, but he says things which he probably won't deliver and doesn't need to deliver even just to impress the audience. But I would say the UK, which has got a great reputation for science, has got to take a leadership role here for the world, because our poor colleagues in the US are going to find it very, very difficult.
And that's what we were, because actually that's just making things actually quite like a new round, if I'm honest.
Do you like me ranting?
I do, yeah.
I can do better than that.
Well, that sounds like there. So, actually, just on the point there a moment, there's a huge amount of public interest in science, and also a huge amount of fake news at the moment, particularly regarding science. Are you concerned about the level of science literacy in the public, in the general public?
I think it's maybe the wrong thing to sort of quite think about, because we're never going to have a public that is as literate as the scientists because of the complexity. So, you know, I'm not bad intellectually, and I talk to my particle physicist daughter, and she's talking gobbledygook, you know, as far as I'm concerned. What we should work on is something that's, I think, a bit different, which is ensuring we have an education and after education, a proper sort of media attention to what it is about science that makes it such a reliable source of knowledge. In other words, to explain that there are ways of working and processes which mean that in a very complex world, science is one of the more reliable ways of producing the knowledge that we need for our futures. Because that is understandable. It's, as you said, reliance on evidence, proper evidence, reliance on good, reliable, reproducible data, a very open mind, a skeptical view, particularly of your own ideas. There's a whole set of criteria. It's not exactly a scientific method. I don't even quite know what scientific method is, to be quite honest with you. But it is a set of ways of working which is effective. And I think the public can get that. Learning the periodic table at school does not convey that. And they're still learning the periodic table at school. I mean, there's a beauty in it when you realise that the elements are ordered in likenesses and so on. But what is important to instill is the way in which such knowledge is generated. And I do not think that we actually focus enough on that. So that's one aspect of it. There are, however, particular problems, social media being one of them. Because when we had, when the public were reliant on mainstream media, television, radio, newspapers, particularly in this country, which actually is, I worked in the US for 7 or 8 years, and I mean, it's terrible in comparison in many ways. I mean, there are some outlets there, but the nonsense that you can hear on some programs is really quite disturbing. But as you get social media, then you reach a significant number of people who are now all in little bubbles, as people say. And the bubbles are self-reinforcing and fight other bubbles. And these notions of evidence, of truth, and of self-skepticism, being skeptical about your bubble. Nobody's in these bubbles skeptical about what they're saying. And yet, as I try to say to my students, I still have students, PhD students, when you have an idea you like, you must be its worst enemy. You should attack it from all sides. You've got to be skeptical of it, because it's only through skepticism and attacking of your ideas that things will actually persist. So social media is a problem because it's bubbles, and it is just reinforcing opinion rather than challenging where we are. So I don't quite know what we do about it, because it's so difficult to regulate. In a way, you say something in the newspaper and it's more subject to libel and so on. I mean, we saw it a little bit with the racist things that actually, in the summer, which was with social media was taken on. But we get Elon Musk saying whatever he likes, for example, and trying to control the world with these bubbles. So I think we need to think about how we can regulate that to make it work. And the final thing I'll say about this is we have to talk to the public and find out what it is that concerns them and what it is that they need to understand better. I learned this about 25 years ago when they were introducing GM crops. You remember tomatoes that didn't go squashy? Remember Monsanto? And there was huge resistance from the public, or from significant elements of the public. But what had not happened is, had there been direct conversations with Joe and Joanna Public, as I might think of it, about what bothered them, okay? And I was then leading a project at the Royal Society. In fact, I wasn't present, I was just doing something on deliberative democracy. I don't know if you people have come about that. And deliberative democracy was it's quite expensive to do, but you get Joe and Joanna Public off the street, you inform them in sort of rather simple language and so on what the issues are and the science underneath it. Then they go around and discuss it in groups, and then out comes what the problems are. And what that process revealed when we went around the country doing this was what people didn't like about genetically modified foods, they said they don't like eating foods with genes in it. Now, you see, we laugh at it, of course, but, you know, they didn't think there were genes in ordinary food, and they thought there were genes in genetically modified food. Now, that took us about a month to find out, okay? But nobody had asked that question. It was all about, oh, you get the tomato and it's not squashed, you know? And the fact that we can, you know, make more money out of it, came into it. So we have to talk to the public as grown-ups, but not to, you know, talking about protons and so on. We talk to them about the things that bother them and what they know and what we have to clarify. And the more we do that, I think the better it will be. And what I do want to say is, having lived in different countries and so on, is that the UK isn't bad at this. And we could make it better, and we could be a beacon for the world, I think. In the US, it's a basket case. Let's be quite blunt about it. You know? It's a basket case. Sorry, yes.
So, I guess we've talked about, in a sense, scientists, we've talked about academia, we've talked about the sort of government policymakers, and we've talked about the general public. And I suppose from a personal perspective, I tend to always sort of think that science and scientists start out at a very young age. It's very difficult to make people interested in science by the time they have reached 18 or 19. I think that sort of curiosity, which I know you've spoken about a lot in science, starts at a really, really young age. And the earlier that we can instill a passion and enthusiasm for science, the better. I guess I was interested in your personal views on this current situation of science education in the younger generation and what that looks like across the UK.
I think you put your finger on it. I mean, you talk to a 9-year-old, they are fascinated by the world around them, including science. They're totally in love with it, okay? I mean, when hormones start producing, it gets a bit more complicated, of course, and they get other priorities, okay? But the primary school kids are really interested. Yet, how many primary schools have got a laboratory? Almost zero. So at the Crick, we set up a primary school laboratory for 7 to 10-year-olds, and we see 2,000 children a year go through it. Every damn university in this country could do that. Every one. I mean, you hire 2 teachers, you get the graduate students and postdocs love to do this stuff. We send out we see 20,000 school kids in Camden each year. No. The places say, oh, we have, you know, an academy associated with us or something. Or, you know, Google DeepMind, I have to laugh at this, Google DeepMind, I know Dennis Haspers, he's a friend of mine, stuff, but Google DeepMind were proudly telling, this is all in Starmer's constituency where we are, was saying, we have 50 summer school students every year, and he said, go down to the Crick, they see 20,000 each year. Anyway, we do need to focus on primary school children, and they will be hugely receptive, because they just are. I mean, coming at 12, 13, you know, I've got 11-year-old, 12-year-old granddaughter, and just beginning to sort of move on. 3 grandsons at 8, who are still pretty positive, but anyway, but they will remember that. They will remember that. Then I do think when we come to school, we have to educate what science is, not just describe it. I'm back to the periodic table, I'm back to, you know, classifying plants or something. We've got to talk about the process and why it's reliable. Now, I'm not an educationist, and I don't pretend to try and lecture teachers and so on. I think we need to listen to them. But we need to have, you see, these days with Google and so on, you can look up almost any fact instantaneously. So the need of an intellectual to remember everything, as would have been the case in the Middle Ages and increasingly even when I was young, we have to remember stuff. You don't have to remember it anymore. You can get access to it. But you do have to understand it, and you do know how to put it together. And you do need to know how to think about it and why it's reliable. And that's really where focus should be in my view. And going to university, there is a textbook called Albert Lasker in molecular cell biology, some of you in the audience may know. And in my lifetime, I wrote a chapter for it when it was this thick, and it's now this thick. Okay, now my lifetime's quite long, so I mean this thick. But what we are doing is simply increasing the numbers of facts, when actually we should be distilling the ideas. And if we don't distill ideas out of this, we will lose our future scientists and our future more generally. And we don't focus enough on ideas. I think we just focus too much on facts.
Sort of indulged in some of my personal questions, because I think there is absolutely something about that education space, some of the role, particularly the Crick has been playing in widening access of science more generally to younger people. So I'm really pleased to have this chance to speak to you about that. But taking us back to evidence-based policy,
yeah.
And I guess it's still quite early days. But have you noticed any differences between this government and the last, perhaps, in the role that evidence-based policy making is playing?
Well, I'm a Labour Party member, so let's just get that out of the way. The Conservative Party did take science seriously. I've worked, I've been a government advisor to on science matters and written 2 reviews, and they were both the Conservative governments. I started when Blair was the Prime Minister. The Conservatives like it. They talk. They will say they support it. I talked to Boris about it, and of course he did a Borisy thing and say, "Oh yes, but did not, no new money and so on." But they focus too much on back to the bright, shiny things that they can say. They love saying, "We have spent 50 million on a new damn computer somewhere," and they do not pay enough attention to the grunge work of how you produce the high quality activities that all of this, because they think it doesn't appeal to the public. Now, I do understand the problem of being a politician, but they have to focus on the grunge as well as the bright, shiny objects. What do we see with the present government? Well, they did give 8.5% increase in a very tight budget on science. I've yet to pick it apart to find out what quite they've given me 8.5%. So if I have a slight question mark in my mind, I'd like to know that a bit more before. But it's for sure, we still got Horizon Europe, we still got everything there, and so that's good. But in the 28 or was it 29 review that I did, I had lots of suggestions which I want them to work on to improve the way we do science, and not simply think, oh, we're going to be the best in electric cars or whatever. That's only at one end, and that will only be delivered if we improve our process. And I've already said that needs money, it needs better organisation, it needs greater permeability, blah, blah, blah. And these are all soluble, not necessarily even with lots of money, but a different way of thinking about it. I am an absolutely born optimist, and I think we will get somewhere. I thought we'd get somewhere in the previous Conservative governments, and we didn't go backwards, but we didn't go forward enough, is how I sort of put it.
So the future's looking bright.
Well, I hope so.
So I'm going to ask you one more question before I throw it out to the audience. And this is again where I kind of want your opinion, and I'm happy for you to rant if you wish. Do you think scientific leaders have a responsibility to speak out against unscientific thinking when they see that, particularly in politicians?
Yes, of course we do.
How do you do that?
Of course we do. Well, it's good to use humour. Why I say that is what we tend to do is get rather pompous about it. So they say some rubbish, you know, we all say rubbish sometimes, but they obviously get a headline. Then we get all pompous about it, and we lose the argument almost immediately with that. So I think we scientists need to be funnier.
Oh dear.
I think we need to have an approach which is a bit lighter, is not pompous, and which will therefore attract more media attention. Having clever little phrases, you know, which have sort of got a witticisms about it, and not sort of lecturing it, we are the scientists, we understand how it all works stuff, I think is better. I really do think it's better. But we should call them out. And we should be calling out, as I said, Trumpisms, I'll use that as a single word, which luckily hasn't infected us too much yet. You know, but I do get worried when our politicians start thwarting it because it isn't evidence-based in the slightest. But we should be attacking. Attacking may be not the right word because that is already making it too, you know, combative. We should be teasing them, making fun of them, just a little bit of mockery. That works. But explaining, you know, that isn't right. But we have to be careful that we don't assume that we are always right. And that is quite a difficult thing to do because sometimes we just don't quite know. You know, let's take COVID. You know, do you remember we all had to wash our hands? We're still washing our hands. We noticed it. How long ago did we find that actually it was transmitted? Not by hands, but by air. What we did was make the best guess of what it was, because that type of virus usually is spread. Pretty soon we found that it was transmitted by air, but we were wrong. Yet somehow we still kept washing our hands all the time when you went into somewhere. Did you notice that? So we didn't even correct that. And I think, I don't know, but I think we didn't want to correct it because it sort of meant that what we said before wasn't right. And we've got to realise we aren't always right. And so when we criticise, there's a certain humility and modesty needed as well as humans. More complicated. I didn't rant then, but it was more complicated.
I'm just thinking, gosh, there's no hope for me because I'm not the science but humorous, so this is not great career advice. I am going to, though, put it out to the audience for questions, if that's okay.
It's okay, and I'm a bit deaf, so shout and speak slowly. Okay? Or you could translate it for me.
We have some mics if people go around, and if you're going to ask a question, please do introduce yourself as well and say where you're from and what organisation you're from as well.
And if I don't answer your question, it may be because I didn't hear it properly, so just ask it again. Hello.
Hello, Paul. Thank you very much for coming for talking. My name is Michael. I'm from King's College London, and apologies if I get this wrong. I'm not a biologist. I'm a physicist. But in your book, What is Life? You talk a little bit about how life is created or how it began. And I think one of the things I think is magical is the idea that a code that is sort of one-dimensional turns into three-dimensional objects, proteins and so on.
The most important thing I said in that book, so well done.
Yeah. My understanding, and I'm a lay person with respect to biology, but my understanding is that ribosomes and other organelles are important in that, and they exist in modern cells. And you talk a little bit about how the best fossils that we have, because we're in a real geological society, are sort of more like modern cells than we would like, and that the beginnings of proto-cells must be much simpler at an earlier stage. What exactly was that process? I know people think about the RNA wild-type hypothesis, but what was that process to get these extra organelles? How did they form? What was caused to begin that magical process?
Well, the short answer is I don't know. The longer, more complex one is it is quite difficult to answer because we are going back 1,500 million years, what the figure I talked about. We're looking at the origins of eukaryotic life in this case mostly. There's three kingdoms of life, bacteria and archaea, which look like bacteria. And then the more complex cells that you're referring to, which are eukaryotes, the others are sort of prokaryotes. And they arose probably around 2,000 million years ago, 1,500 million years ago. And they think that the organelles arose, of course all of this is guesswork, but it's pretty reasonable. They think that a sort of proto-eukaryotic cell engulfed another cell type, a bacterium, like a mitochondrion or a chloroplast. Not ribosomes, but they are just protein aggregates. And then they built a sort of symbiotic relationship. And if you now look at a modern cell and you see a mitochondrion, it's actually the remnants of what was another organism which it engulfed. And that is the best sort of understanding of it. The real problem I have with evolution of life is how on earth it all started. Because, you know, the Earth was formed about 4.2 billion years ago, or 4.6 billion years ago, cooled down and up maybe by 4.2. And yet we have 4 to 4.2 billion years. We have clear fossils by 3.5 billion years ago. So in 500 million years, 500 million years, we have life. Now, 500 million years is obviously a long time. I'm not saying it's not a short time. But we then, to get proper multicellular life, we go from 3.5 billion years ago to 700 million years ago. Now, I cannot see why it took so long to produce multicellular life when we produce cellular life, which I can't imagine how that came about, in 400 or 500 million years. There is a big mystery here, and I don't pretend to know the answer, but it is really, really interesting. But the question you asked about the different structures, I sort of think that the idea that they're engulfed other cell type probably is the answer.
Any other questions? Oh, God.
I think there was some, yeah.
Hi there, I'm Natasha Stephen. I'm the Director of Science and Engagement here at the Geological Society, so thank you very much for coming this evening. I wanted to go back to your point that you talked about sort of end-to-end funding, because in our experience we created a new funding scheme this year, £2 million, to allow people to apply for funding for seed corn research ideas, and it was open to everyone. For people that are typically locked out of UKRI funding, for example, so technicians could apply, people with non-permanent contracts, those returning from career breaks. And one of the other things in this award was people could cover those hidden expenses of research. So if you had caring responsibilities, for example, or you needed adjustments to be able to conduct your research idea. We had some fantastic applications, but we didn't have anywhere near as many as we were anticipating we might have had. So I just wondered that obviously the way we communicate what that award is and who it's for is one thing, but is there a bigger challenge with funding, particularly in the UK, for how we can, you know, match people and ideas up with the resources that might be available to them? Is it as simple as just communicating it?
Well, I do think we need to basically the way we do research grants and funding is the same as we did 50 years ago. There's not such a big difference. The difference is that the infrastructure in institutions has been whittled away, which used to support some of the end-to-end funding. You're talking about in some of the initiatives which sounds a very good initiative, support the individual, you know, if they have, say, childcare issues and so on. But in addition to that, it's just the end-to-end funding of supporting. So you're not doing the washing up. I mean, washing out tends to be done, but all those sorts of things that can be done more effectively, communally and core funded is what I'm thinking. So I think the sort of experiment that you tried there is exactly what we should be doing. We should be experimenting now with different ways of doing it. And I actually suggested that in my review. It wasn't specific, but what I was saying is we should think of what we might do and try things out. Just see how well they work. Why did you think you didn't get as many applicants?
I guess having been in that situation and talking to people informally, particularly via social media before it went a little bit sour, we shan't name the platform again, there was a lot of interest in sort of those hidden costs and, you know, just being able to provide a little bit more freedom than some of the other research grants to free people up in terms of like their capacity, just, you know, physically, mentally, whatever it is that they need to test out an idea, test an hypothesis and see if they can get somewhere with it. We knew that a lot of people were really excited about the idea, but then when the application round opened, and hopefully it will be an annual thing for a few years, but when it opened, we had far fewer final applicants.
And you don't quite know why that was the case.
Absolutely no idea, because everybody that inquired, we encouraged, and we had lots of conversations that led to applications.
How much money, what's the quantum, what was the quantum? I mean, how much money?
It's £2 million over 3 years.
Yeah, but for each individual?
Up to £100,000 average. It could be more than that, but it was only for a 12-month project.
Well, the thing I only would say is that we can think of good ideas and try, or ideas we think are good. We need to test them and find out whether they work in practice. And obviously something, if people are not applying, there's something that needs extra to be done. And you need to think about what it might be. But that is just the process. What we've stuck with, in my opinion, is too much of a monolithic way of working. And we've not experimented with different ways. Because I was privileged enough to have an institute and a big core funding, it was no more than what was there before, but I could manipulate it in different ways. We tried things out, which and it's a bit off what the question is, but it's in the same category. I mentioned technical cores. In the life sciences, but actually in all sciences, you need high quality technical cores. Getting support for that is through UKRI is incredibly difficult. The universities do not have them. I mean, they have them in a fashion. Even in the US, they don't have them. But if you do have them, it's transformative, because we have 18 different high-quality technical cores where every scientist has access to them. Now, there's several consequences of that. One is that you don't have to be an expert in all these different technical cores. You've got them actually there, and you get access to it. So immediately you can expand how you would do things. You don't have to do a collaboration with somebody and set it all up, and then they can just walk away. It's actually there as part of what you do. Secondly, it's cheaper, because actually you've combined all the requirements into one place. So instead of every individual group having to set up the facility and the group leader becoming the king or the queen in that area, and their groups get too big so they can't even run them properly. We keep groups small. It ends up being very efficient too, financially. But why don't the research councils look into this? They don't. I mean, they're still doing it as we did in the Stone Age.
Another question just in back there.
Hi, Rob Bradley, Institute of Water. I'm the Professional Standards Manager. I used to describe my career as being more of a verb than a noun, so it's kind of reassuring to hear there are other people out there as well that have chopped and changed quite so much. I was curious in your wee biography there about the difference between, what would you say, a fast walk and or a brisk walk and a slow running? And the reason I ask that is just that time to think, which I advocate for people who are doing CPD to take some time to reflect on the changes. So, fast walks.
Well, if I've got the question right, I run a research group. We work at the very borderlines of knowledge, and we fail frequently. You know, the different types of science. If you're a bit further back from the very front end of discovery, you're consolidating. You can be more efficient and effective. You know the experiments to do. Our hypotheses are clear. You can do sort of Karl Popper type things really straight sort of forwardly. But if you're at the discovery and you fail a lot, you know, at the very front end. Why do I say that? Well, I say it because it's psychologically really stressful. So I have PhD students and they can work for 6-9 months and have nothing. Not because they're no good. In fact, it may be because they are good and are trying to deal with a difficult problem. So when you come to the slow, fast walk, slow run, I tend to say, if you get into that situation, go on holiday. Just go away. Go on holiday. I did it actually only last month. One of my students was, struggling doing it, couldn't reproduce it. I said, go on holiday. Go away. Stop it. Now, why? Because, they're getting nervous, they don't quite do it. We're artisans, we have to sort of do things with our hands as well as our brain. And she was probably messing that up. But also, you start to think on rails. So I would take a railway metaphor rather than a walking metaphor. When you think you understand something, you tend to be on a railway track, and it's the only way you can think about a problem. Yet often there is another railway track over here which is equally good, but you can't embrace it because you're on your railway track. And one way to get over that problem is to stop thinking about it. So the rails sort of disappear a bit. And then when you come back to it, you can build up maybe a different railway network. So it's almost, rather than slower walking, you just stop walking altogether and go and do something else, and then come back, and maybe you'll walk in a different direction. If we're not using too many metaphors.
So any further questions? Oh.
Yes, please.
Hello, good evening. My name is Carolina, and I'm just finishing my PhD in archaeological science in Oxford.
In which in
Archaeological science.
archaeological science, great, yeah.
So I'm at the beginning.
You have lots of radiocarbon dating, maybe.
Yes, in fact, we do radiocarbon dating and we reconstruct diet, and it's all very exciting. But my question is very down to earth. You mentioned that you work with PhD students and young researchers, and as you, I'm sure, are aware, and everyone in this room, it's extremely competitive for young people who are starting our path, and there are lots of our colleagues who might not stay in research because it's so competitive. So it's mostly people who are so passionate that they wouldn't let go. Based on your experience with young researchers, are there any gaps? Is there anything that we can change in our thinking, in our approach, especially at the beginning of the career? Not just to have a successful career in science, but to really truly contribute to the society. You spoke very interestingly about our input into policy, but at the very beginning of our way, is there something that we young people could be doing better?
Well, I'll make a few observations. One is, it's actually always been like that. People think today is very different to how it was. It's always been a struggle to make a career. And personally, I applied for, I don't know how many university lectureships, which I didn't get. Okay, so it has always been, you use the word competitive, but I'd say it's always been difficult. I mean, to make a career. So it's, I don't think, really so different now from when I was a PhD student. But I think what the question you ask is the right one, because not everybody should become a research scientist. In fact, they can't. I mean, but you learn something from being a PhD student that, if done well, should be transferable. You should have learned how to think. You should have learned how to tackle problems. You should have learned some of the joy of it, when it works. Once every year, of course, but when it works. And I do think we don't advise our students well, because the problem is that academics like me have only been academics usually, and that's the only world they think of. And so there's a tendency that, if you're not going to be an academic like me, you've failed. And that's just depressing and not true. So I do think that, and I set it up in the Crick, with resistance from my colleagues, and it's not as extended as I would like, that during the PhD we provide opportunities for them to explore other career options and spend a week, 2 weeks, a month somewhere else, just learning or being exposed, I should say, to other careers, like teaching or working in a patent office or whatever. And that's often resisted because the group leader thinks they've got their people doing their research and now they spend time off. But we have to think that we're dealing with an individual who may not actually want to be a professional researcher. And so we have to provide them with the skill sets that allow them to transfer what they have learned being a researcher into other sorts of fields. I'm not sure you're agreeing with this looking at your face. Do you want to come back to me?
Well, thank you.
Well, I've been specifically thinking about those people who would like to stay in research or are very determined.
Okay. All right, let's talk about them. I mean, that's people like me. You have to be utterly determined and driven to the point where you can't imagine any other life. It's sad, but utterly driven. If you are utterly driven, somehow you usually find a way through. I couldn't get into university. I told you I couldn't get a job later because I was working on something that people thought wouldn't deliver. Okay, it wasn't trendy at the time, and you just have to be completely driven. I took my poor wife. We went. When I was going to start my postdoc, my PhD was dreadful. Okay, I have to say. I thought I have to do a project that if I'm going to suffer this much, it's got to be something decent. So I devised this project in my head of looking at the cell cycle and its control. When I was a PhD student, I wasn't working on that, and the approach of using it, which was genetics. But the problem is, I wasn't doing cell biology, and I wasn't a geneticist. Okay, so I had to get a grant, 2 different grants. I found a lab which would accept me as a postdoc, but I had to get a fellowship. Okay, no money there. And I needed to be trained in another area to go to another lab to get there. So I had to get 2. I mean, crazy. Again, it should never have worked. I got money for the training. I went to Switzerland from the Royal Society, actually, which is why I love the Royal Society. They gave me money, and it was old school. So they said, how much money do you want? So I wrote down the lowest amount I could imagine because I thought I'm more likely to get support. So I got this low amount and I went to Switzerland. Now the cost of living in Switzerland isn't actually that low. And I tell you, I was going there for I think it was a 6-month period the first time. And I completely run out of money in 3 months, and I was living in what's called Gastarbeiter accommodation in Bern, which has no bath or shower and no hot water. Okay, just good. It's the only thing I could afford, and I still ran out. So I wrote back to the Royal Society and said, I've run out. And the next week they sent me a cheque for the same amount I asked for in the first place, exactly the same amount, and said good luck with the next 3 months. Okay? I'm sorry, but the NRC wouldn't do that anymore. Absolutely certain. In the end, I had to live with my professor looking after his children. And because I got free accommodation, I did babysitting and then worked in the lab. Now, and my poor wife was following me around wondering what the hell she'd done if she married to me, of course. But it was, I was very determined to do it. So I think my only answer is passion. If you're passionate, you probably will get it to work somehow. Does that help?
What a fantastic amount of advice. I'm going to ask if there's one final question in the audience.
At the back.
Chris Golds with the IMRS. I'd like to say thank you very much for a fantastic high-flying level of achievement, the lecture, the content. It's been fascinating. If I may, I'd like to ask a low-brow but high-flying personal question,
Yeah.
noted from your bio. As a glider pilot, where do you fly from? What do you personally get out of it? And how would you recommend it to fellow scientists?
You're right, I'm a glider pilot. I'm beginning to wonder if I'm getting too old. I fly from Weston-on-the-Green, which is north of Oxford, where I live at the weekends. I have a house in Oxford, actually, which is why I know about the archaeology thing. I was a trustee at the British Museum, actually, about archaeology. I fly a nice single-seater, you know, and decent performance. Do you know what I like about gliding particularly is, I tell you, I do not think about my science when I'm flying, at all. I'm thinking about surviving and staying up. Are you a glider pilot too? Yeah, okay. I've flown in the Alps and the Pyrenees, which is a completely demanding thing. I've abandoned doing that as a solo pilot because I am getting ancient on it. But I can still sort of float around in the Oxfordshire countryside because if I run out of lift, I can almost certainly get it down somewhere. I've had a number of incidents in my life. What do you fly?
I have a Pilatus and Duodiscus.
Duodiscus is beautiful. The Pilatus I'm less keen on, but the Duodiscus is beautiful. Beautiful balance control, you know what I mean? Yeah. Yeah.
What an exceptional conversation. Would you indulge me just in one final question? Would that be okay? Just almost sort of inspired by the last question, what would you like to be known for? What would you like your legacy to be beyond your scientific achievements?
Oh, well, I mean, it will be my family, I guess, you know, to at least brought up my children and been a reasonable husband and all that sort of thing. I think that's what it is. And maybe, you know, I'm going to sound like being a decent human being.
Gosh, I can't imagine a nicer way to spend a Tuesday evening. I dare anyone to find a better Tuesday evening than this one. Paul, this has been absolutely fabulous. You've indulged me in very far-reaching questions.
Thank you.
You agreed to sign up for tonight. It has been an absolute personal pleasure and privilege to sit here and have the opportunity to speak with you. And I thank you on behalf of everyone that has the pleasure of sitting in the audience this evening.
You're too kind. Thank you very much. Thank you.